Welcome back, math fans. We are going to continue our study of chapter 5 with a slight deviation from the norm. We are going to venture into the wild world of polygons. And unless you have recently had high school geometry, this may be a little bit new. It may take a little bit to refresh your memory, but that's okay. You're not getting any judgment from us. We are going to start from the very beginning with the definition, sort of a polygon. So we say, officially, a polygon is a closed figure with straight sides that intersect only at their endpoints. And FYI, nifty fact, these endpoints are called vertices. If there's only one, it's a vertex. If you're lucky enough to venture into college algebra, you will talk about the vertex when you talk about different functions and their graphs. Another fun fact, I'm full of those today. Okay, so you guys know by now that I am really a stickler for examples and non-examples. So let's talk about some examples of what a polygon is and also what it's not. So one of the things it says, it has to be a closed figure. So what that means is we can't have something that looks like that. That thing is wide open. If you put it out in the rain, it would fill up with water. So what else could we draw? Well, it has to have straight sides. So if we're going to close it, and it's got to have straight sides, it could look like that. Granted, it wouldn't have that little tail thingy sticking off, but that's okay. I had a question a long time ago that said, well, Ms. Graham, what do you mean straight sides? Like, what would it look like if it was a closed figure without straight sides? Well, it might look like that. Kind of like an ice cream cone looking thing, but flat instead of 3D. Or it could be a circle. That's a closed figure, but it doesn't have straight sides, so it is not a polygon. Another example of a polygon would be the one with the least possible number of sides. A triangle, you're all used to those. Now this last part says that the sides only intersect at their endpoints. What does that mean? Well, this is what that means. This means that you cannot have a shape that looks like this. There we go. I do have a closed figure. That thing is not going to catch water. It has straight sides. There are no curves. But this is a problem right here. This is not one of the endpoints for the sides. My endpoints are right here. This is not a vertex. So we can't have something that looks like that where the lines cross in the middle. Now, if I wanted to add a whole bunch of sides, that would be totally fine. It doesn't have to be a normal looking shape. It can have all kinds of sides and all different kinds of angles and still be a polygon. So now we're going to take a look at different types of polygons. Don't worry, we're not going to get crazy with this. We're going to talk about the basics. First one is a triangle. Hopefully, we all know that by now this is a three-sided polygon. I don't need to write the number 3 and then write the word 3. You guys get the point. There are two different ways we typically classify these guys. The first way is by their sides. And that is this first row. The other way is by their angles. We'll talk about sides first. When we talk about their sides, we are interested in how many congruent sides they have. Congruent means same size, same shape. So a scalene triangle that's how you say it, scalene. Please don't spell it that way, but that's the way it is said. This has 0 equal sides. So all of the sides on one of these guys are different. Now, just in case you draw a triangle on your paper that looks like they might be the same size, all you have to do is write different numbers on each side, because when we talk about geometric figures, we tend to trust the numbers and not the pictures. Now, an isosceles triangle there you go, has 2 congruent sides. I don't want to say exactly. That's getting a little picky. Let's just go with 2 congruent sides. Remember, congruent means equal. Let's say that this side is 10, and this side is 10, and this side is, I don't know, 3 sounds good. 2 congruent sides for an isosceles triangle. Equilateral triangle, if you look inside this word, you see 2 pieces. You see equal, and then right in here with this really terrible brown color, you see lateral. Lateral means sides. So in an equilateral triangle, you have all equal sides. And I'm going to tell you now, these are not all going to look the same, but they will be the same because I'm going to mark them that way. So you have equilateral with 3 equal sides, isosceles with 2, and scalene with 0 equal sides. So we're going to switch gears and take a look at classifying by angles. We have 3 options there. We have an acute, an obtuse, or a right. An acute triangle doesn't have freckles and a little bow in its hair. An acute triangle has all angles less than 90 degrees. All of its angles are acute angles. So we could make this one, I don't know, 70 degrees. And we could make this one 70 degrees. And this one 40 degrees. And those would be all acute angles, making this an acute triangle. In an obtuse triangle, remember that an obtuse angle is greater than 90 degrees, not greater than or equal to, but strictly greater than 90 degrees. So we need one big fat angle. That is bigger than 90 degrees. We will say that this is 160 degrees. That could leave 10 for this guy and 10 for this guy. How do I know? Well, there happened to be a total of 180 degrees inside a triangle. Every single triangle, the total number of degrees on the inside is 180. So I'm not just making these numbers up. The last type is a right triangle. This guy has exactly, and I'm not changing my mind this time, exactly one right angle. Remember, a right angle measures 90 degrees. That's why if you are ever really cold, go stand in the corner of the room because it's always 90 degrees. It'll be warmer there. So here is our happy little right triangle. I'm going to put a little square in this corner. That is the universal symbol for a right triangle. When you see those, it is very safe to assume that that angle is 90 degrees. If that one is 90, we'll say this one is 40 and this one is 50. Could be, they may not be if you measure them, but they are because I say they are. That's one of the perks to geometry. So now let's take a look at some quadrilaterals. These are the only two special groups we're really going to look at. So don't run screaming from the room. Quadrilaterals have a clue in here too. They have the word quad, meaning four. And then they have that lateral word in there, meaning sides. So the name quite literally tells you what it is. It is a four-sided polygon. That means all of the rules for polygons still apply. These are still closed figures. They still have straight sides, and they only intersect at their corners, at their vertexes or vertices. The first kind that, and the most general type, I guess, is a parallelogram. Now, a long time ago in a galaxy far away, you talked about the idea of two lines being parallel, and that meant that the lines would never intersect. And while that is not quite the right definition for parallel lines, it's good enough for what we're going to do here. In a parallelogram, in order to be in the parallelogram club, you have to have two pairs, two pair of parallel sides. Typically, we draw a parallelogram looking like a rectangle that somebody leaned on. And to indicate that their opposite sides are parallel, we put the same number of arrows on each member of the pair. That indicates that they are parallel and that they will never intersect. There are some other things that go along with the two pair of parallel sides, but that's the big one. All of the others tend to follow from that. We're going to narrow these down as we go. A rectangle, I promise you have never thought this deeply about a rectangle before in your life. You may never again, and that's okay. That's close enough. A rectangle is a parallelogram. It still has, yes, that side is supposed to be parallel to the others. Don't judge. This is still a parallelogram. That looks weird. No, I spelled it right. But now we have the condition that it also has 4 right angles.
You should have done a trapezoid because then you could really fold them. Right?
Mm-hmm. So we're getting a little more specific in what you need to join the club. So we have our parallel line indicators on there, and we have our right angle indicators in there. Next, we're going to take a look at a square. I'm going to get as close as I can get. Don't judge me. That's pretty terrible. That's still pretty terrible. Oh well. It's a parallelogram. So we still have 2 pair of parallel sides. A square still has 4 right angles, so we get everything the rectangle has.
I already did. I did get my boots.
We have 4 right angles. But now we add in the idea that all of the sides are congruent. So they're all the same length. When we want to indicate that on a picture, we put the same number of little tick marks on the side. I'm also just going to put some numbers in there so that it's pretty obvious when you go back and look at your notes, because I know everybody goes back and studies their notes, that they are in fact all the same. The last piece of this is the trapezoid. The trapezoid is kind of the oddball. It's still a parallelogram. So we still have 1 pair. What am I saying? It's not a parallelogram. Let's see if I can make this longer. So in a trapezoid, this is not a parallelogram because in a trapezoid, we only have 1 pair of parallel sides. The other sides may or may not be congruent. Sometimes you get right angles in the corner, sometimes you don't. We only have 1 pair of parallel sides. It's kind of the oddball. We're not going to go into detail on the other types of polygons. We're going to cut it off there. We do need to go and look at the different prefixes. These come up a lot. So we've already talked about triangles, like a tricycle. It has 3 sides. We talked about quadrilaterals, quad meaning 4, so it has 4 sides. Penta. Penta stands for 5 sides. We call it a pentagon. Hexa is for 6 sides. We call this a hexagon. Hepta is 7. This is a heptagon. Octa, like an octopus, has 8 sides. Nona is not one that gets seen a whole lot. Nona is for a nonagon. That has 9 sides. Decagon is like a decade. A decagon has 10 sides. A hendecagon is not something you are going to see very often at all. That has 11 sides. A dodecagon has 12 sides. And now, luckily for you guys, and for me, because I get tired of writing all of these out, but when we get larger than 12, we've already talked about how math people are inherently lazy and we like to take the shortcuts. If you get larger than 12, so if you have 15 sides, we call this a 15gon. If it had 50 sides, we would call it a 50gon. So if you have n sides, as long as n is greater than 12, we just call it an n-gon. I know you're incredibly disappointed we're not taking this all the way out to 100, but you'll be okay. The last thing that's a general property of polygons is the idea of convex versus concave. And this is really more about how the polygon is formed, not really how many sides it has or anything like that. When you have a convex polygon, what that means is that when you draw it, all of the vertices are going out. Versus concave, think about a square. And you used your finger to put a dent in one side. It caved in. So a concave polygon, I'm going to make that arrow go the other way, has a caved in part that looks like maybe you hit it with your car or you poked it with your finger, kind of like when you poke a marshmallow and it makes a dent in the side of the marshmallow. Don't lie, you know you've poked one. Convex, all of these guys point outward. That is a quick rundown on polygons. If you want to know more, I will be happy to nerd out for you. Come by my office and we can absolutely talk. Otherwise, stay tuned for the next installment of Chapter 5.